Hello, so this is chapter 2, section 7. This is the last section for this chapter, so we're going to have a chapter review and a test here soon. This is solving radical equations. Okay, so everything we've done so far has been with expressions. This has an equation. So what we're going to do is we're going to be looking at something that looks like this. Solve for x. And the equation is going to look like the root of 3x plus 3 equals 3. All right, well, when you do these, we already talked about the fact that exponents and roots are inverses of each other, so you can undo one with the other. So you're going to have some steps to do when you do these. And the first thing you want to make sure that you do is isolate the radical by itself. That's what isolate means. On one side of the equal sign. Now that's already done in this equation, okay? This radical is all by itself, and it's the only thing that's on the left-hand side. So that's done already, okay? The next thing that you're going to do is you're going to raise both sides of the equation to the power that matches the index. Remember, the index is right here. If you don't see one, it's a 2, right? And why do we want to do that? We want to eliminate the radical. The root, okay? So in this one, let me rewrite this. If I have the root of 3x plus 3, and that whole thing is under the root, equals 3, I'm now going to take this, and both sides, if my index is a 2, I'm going to square both sides, okay? Well, what does that do? Well, the square eliminates the radical, so on this side, I only have 3x plus 3 left. And on this side, I square the 3 and I get a 9. Okay, so that eliminates the radical. And now you solve like a normal linear equation. Okay. So I'm going to move the 3. And then I'm going to divide by 3. Okay. You are not done once you solve. You need to make sure with all of these that you check. A lot of times, like for this one, there's only one answer. Clearly there's only one answer. But sometimes you're going to get 2 answers, and in varsity you're only going to have 1 box, so it's clearly only going to have 1 answer. But if I was to check this thing, I would have the root of 3x plus 3 equals 3. So I want to plug the 2 in for the x. So I have the root of 3 times 2 plus 3. Well, this is 6, 7, 8, 9. So I have the root of 9 equals 3. Well, the root of 9 is 3. So this is 3 equals 3, and it checks. Okay, so you want to make sure that you're doing that for every one of these when you solve them. Okay, let's take a look at another one. So here, I'm going to solve, excuse me, the root of 6y plus 1 minus 2 equals 3. Well, recall that the first step is to isolate the radical, okay? Well, here, the radical is this piece. right? So this is not under the radical, the -2. And this needs to go to the other side by doing the opposite operation, just like a regular equation. So I'm going to add a 2 and add a 2. So now I have the root of 6y plus 1 is equal to 5. Well, now the radical is isolated. So now I can go through, square both sides, because that thing is a 2 here, right, if you don't see one. So the square cancels the root. So I get 6y plus 1 equals 25. And then subtract off a 1. 6y equals 24. And then divide by 6, divide by 6. So y equals 4. And then we're going to check. The root of 6y plus 1 minus 2 equals 3. And I'm going to substitute in the root of 6 times 4 plus 1 minus 2 equals 3. This is 24 plus 1 is 25, so the root of 25 minus 2 equals 3. Well, the root of 25 is 5. And 5 minus 2 is 3, and that equals 3. So that checks. When you check, excuse me, remember that you are going for your left side equaling the right side. You're not supposed to manipulate like this side over here because it's already equal to it. You don't change that. You need to do the math on the left-hand side to make sure they equal each other. And I will be looking for these when I see your work. Okay, so make sure that you're showing those. All right, let's do one to a higher power, and then we'll go and do one of the more difficult ones. Okay, so we're going to solve. We have the fourth root of 5x minus 1 is equal to the fourth root of 4x plus 5. Oh, don't let this freak you out. It's really not that hard. Okay, so the radical's isolated. There's two radicals. They're both isolated, but they're raised to the fourth root. So we're going to take these and simply raise them both to the fourth power. What's that going to do? The fourth root cancels the fourth power on both sides, and now I have 5x minus 1 equals 4x plus 5. And now I solve like I normally would. So I'm going to subtract a 4x, subtract a 4x, add a 1, and I get an x equals 6. All right, so let's check this and make sure it actually works. So the fourth root of 5x minus 1, oh, I should have put a 6 in there, is equal to, well, I'll just rewrite the problem, 4x plus 5. All right, so if I put a 6 in here, 5 times 6 minus 1, and 4 times 6 plus 5. So I have 30, 29, fourth root of 29 is equal to 24, the fourth root of 29. All right, well, those two things are definitely equal to each other, so that checks. Okay, so a hard one. Actually, there's two more that we have to do. All right, just to make sure that you're aware of what's going on. So this one, solve the root of x plus 4 is equal to, this is funny, that one's a root and one's not. Okay, notice that the radical is already isolated. It's done. So what we're going to do here is square both sides right off the bat. So this side on the left is easy, right? This cancels this, and I have x plus 4. This side, however, is where people are going to make mistakes. They're going to want to say that's x squared plus 16. Well, it's not. This means there's two of those, right? So this is really x plus 4 times x plus 4. And then you got to FOIL this out. And if you can do the foiling if you need to, but that's going to be x squared plus 8x plus 16. Okay? So you can check that if you'd like. Now your goal is to solve that thing. And whenever you want to solve an equation, you need to set it equal to 0. I don't know why people don't know this, but it has to be set equal to 0. So I'm going to move both of these over here. So I'm going to go minus an x and minus a 4. So that's going to give me x squared plus 7x plus 12 equals 0. That has to happen, right? And now you can probably factor that thing. If you need to go to x method, you can do that. 12 is going to be x plus 3 and x plus 4 equals 0. But if you needed to go back to x method, right, you'd put a times c on the top, b on the bottom, two things that multiply to the top and add to the bottom, divide by a, and then these values go up into your binomials. So that's a review way back from, what, 1.3 or something. So now you have to take these and set these equal to 0. So I have x plus 3 equals 0. Move the 3 over, so x equals negative 3. And x plus 4 equals 0. And x equals negative 4. Okay, so this is probably an example where one of these is not actually going to work. And if you take a look at putting these up in here, if I put a negative 4 in here, so if I go here, the root of negative 4 plus 4, well, that gives me 0, right? And the root of 0 is 0, so that's fine. And over here, I would get negative 4 plus 4, that's also 0, so that's fine. But what if I do the root of negative 3 plus 4? I get a root of 1, that's 1. And then on the other side, I do negative 3 plus 4, that's 1. Okay, so both of these actually work. These are both fine. And they should both check for you. Okay. Okay, ready? Here comes the big dog. You're going to have one of these for sure in varsity. There's also going to be one for sure on your chapter test. Pay attention. I'm going to need an extra screen, I'm positive. So let me clone this page. Let me actually make 2. They take up a lot of space. And I may not finish it. It's more about process than about how to get where we need to go. Because it starts out like the last one. Okay, but this one, you might want to highlight it, pay attention. So we have solve the root of x minus 5 is equal to the root of x plus 2 and then minus 1. And that minus 1 is not under the radical. So this is an occasion where there's no way to isolate either radical. Okay, so we're going to square both sides and see what happens. So we're going to square this side and square this side. And it's going to get a little bit ugly on the right-hand side. So the left side's easy. This cancels out this, and we get x minus 5. This side, however, is going to be the root of x minus 2 minus 1 times the root of x minus 2 minus 1. So when I FOIL this big ugly thing, I'm going to have the root of x minus 2 times the root of x minus 2. Well, we know that when I multiply a root times itself, I get just x minus 2. Now I'm going to multiply the root of x minus 2 times negative 1. So I'm going to get negative root x minus 2. This is going to give me the same thing. And then I have a negative 1 times a negative 1, which is a positive 1. All right, so I have an x minus 5 over here. We just bring this down. Okay, so next line. I'm going to combine some like terms here. So I have the negative 2 and the 1. Let's just bring down the x minus 5. Then I have x minus 1. And then these two are like terms. Remember, there's little negative 1s in here. So this is going to be minus 2 root x minus 2. Okay, so now you need to move these to the other side and isolate the radical that's left. Okay, so we're going to subtract off an x and add a 1. That's going to get rid of both of these. It's going to get rid of these x's. So this is going to give us a -4. And then I'm going to square this. Well, watch what happens here when I square this. This is going to get squared, right? Because it's a coefficient out in front. So a -2 times a -2 is a 4. And then this is going to drop this, but because there's a coefficient, I'm going to put in a set of parentheses, and that's going to happen, okay? So make sure that you're aware of what's happening. And now I'm just going to do some good math and solve. So I'm going to distribute. So this is going to give me -4 equals 4x minus 8. I'm going to bring this guy over here because I need it set equal to 0. Maybe I won't need this other page. So we're going to go plus a 4. So I have 4x minus 4 equals 0. I'm going to bring the 4 to the other side. So 4x equals 4, and x is going to equal 1. Okay? So that's how that thing's going to work. You do have to square twice. So that's the method to get this done. And there's lots of places for you to make boo-boos, but give it a try, see how it goes. And again, if you need help, please, please, please make sure that you ask for help, okay? I think I've covered most of what you're going to see in this section. There might be a couple of surprises in varsity. Don't hesitate to ask if you need some assistance, okay? Toodaloo for now.